Hi everyone, welcome to our introduction to PV Assist fourth video, and in this video section we will try to start and complete the system part for our two tilted rooftop system project. And I want to make a reminder that in this section, as you can see, this is the section which is colored as blue. It says please define the system. As we move forward with the PV system, the forward steps that we should do is pop up in this blue colored screen, and the things that we have to do is wrote as guidance for us. For example, for our next step, it says please define the system. We will go to system part and start to define our system. First part in the system, it says sub-array name and the orientation. As you remember, for the orientation, we don't have just one orientation. We have orientation 1 and orientation 2. It says for your orientation 1, your tilt is 6 degree and your azimuth is 36 degree. But since we deal with the two tilts at the same time, I choose mixed orientation 1 and orientation 2 option. And it gives us both the orientation 1 and orientation 2 tilt and azimuth values. In our previous video, as you remember, we tried to calculate the tilt and azimuth values for our system. And when we come to the precising help part, it says you have two options, whether you will enter the planet's DC power of your system. Why I set the DC power? Because at the right hand side of this place, as you can see, it wrote kilowatt peak. When we encounter with the kilowatt peak, it refers to the DC power. It refers to the power that is in the DC form. But when we encounter with the not the kilowatt peak, but the kilowatt kilowatt I mean kilowatt electric, we should understand that this term refers to the AC power. And since it says kilowatt peak, kilowatt P, it wrote in that way, we should understand that in that section, whether we have to write the planet power of our, DC planet power of our system, or as another second option, if we don't know the exact planet power of our DC power of our system, we can enter the area of our roof, so that PV Assist will give us some panel calculations, string calculations for our system, for our current system. But since we assume that we work professionally and we try to do our job in a most accurate manner, the version that we move forward with the planet power, DC planet power, is best for us because it gives us more accurate values when we move forward with the project. And to understand what is our DC kilowatt power in our project, we should turn back to our AutoCAD file, our CAD file. As you can see, this is the panel placement, the AutoCAD file, CAD file that includes the panel placement of our system. And at the below, it says we should have, according to this placement, we should have 432 panels, and we should attain 237.6 kilowatt peak DC power for this project. But also, As you can see, I wrote for the left-hand side, I wrote 216 panels for the left-hand side, 216 panels for the right-hand side, and also 118 power 8 kilowatt peak for the left-hand side and 118 power 8 peak for the left-hand side, and for the kilowatt electric, it's also the same. 100 kilowatt electric for the left-hand side and 100 kilowatt electric for the right-hand side. But why I wrote in that way? I mean, what means the left-hand side and what means for me for the right-hand side? Actually, when we are trying to draw the CAD file, I mean panel placement of our roof, as you can remember, this was our whole roof. But we said that in this project, two roof, as you can remember, this was the first roof and this was the second roof. These two roof stays side by side. And this was the intersection point of the two roof, and these lines was the ridge of the roof separately. And when we come back to our AutoCAD file, in order to understand the depiction of this AutoCAD placement concretely, we can say this is this yellow green line is the intersection point of the two roof. This line is the ridge of the first roof, and this line is the ridge of the second roof. And as you can imagine, the tilt of the first side of the first roof, I mean the first tilt of the first roof, and the second tilt, and the first tilt, sorry, the first tilt of the second roof. Their face look, I mean, they face towards the same direction. The first side, the first tilt of the first roof, and the first side of the second roof face towards the same direction. And in the same manner, the second tilt, or in another name, second tilt of the first roof, or the second part of the first roof, and the second tilt of the second roof again face towards the same direction. And the directions, I mean the first section of the first roof, first tilt of the first roof, and the first tilt of the second roof, I named these tilts as the left-hand side. And for the second part of the first roof and also the second part of the second roof, I named this sides of the roof that face to the same direction. I named them as a right-hand side because they it is just like for imagining and naming, just like they are looking to the right-hand side. And I said that for the left-hand side, for the panels that is located in that area, and plus in that area, is totally 216 panels, and when they are connected to each other, we will attain 118.8 kilowatt peak DC power. And for the right-hand side, I mean the panels that is located in that side and plus in that side, which face to the same direction, and I named it in order to give concrete sense. I named like that. And when we sum up that panels, they correspond to 216 panel, and when they are connected to each other, we will attain again 118 0.8 kilowatt peak for our project. I just want to explain this part so that it will be clear for us. What was the total DC power of our project? Yes. When we come to the PV module section, there are different options that is loaded in the PV system automatically, so much brands and also the so much models of that brands. Also, I want to say that we can download. We can upload some inverters and also the panels. Okay, when we come to the panel selection part, as you can see, there are so much brands and also the models that is related to that brands. And also I want to say that we can we can upload some panel and inverters to the library of the PVSys. I mean the panels as PAN file and the inverters as OND file. And maybe in another other video we can record how we can upload the new panel and inverter to the PVSys. This can be another video topic for us. But just for moving forward with our project, as you remember our AutoCAD file, CAD file. When we go back to our CAD file, we will encounter that our solar panel in the solar panel technical specification part, it says, it gives us the panel datasheet informations in that section. Information is given, also temperature coefficient of voltage drop and the temperature coefficient of the current drop is given. And also the dimensions of the panel is given. The length and width of the panel is given. When we come back to the PVSys, I want to choose the Schmidt-Peckinpah as the solar panel brand. And as for the model, I want to choose 550 watt peak monofacial panel of the Schmidt-Peckinpah. And then in order to verify that or selected panel, Schmidt-Peckinpah C-Mono SPE 550 model panel is compatible with the panel that is located on the AutoCAD file, we can just make a comparison about the panel informations that is located in the CAD file in order to make a verification, and the informations that is given in the PVSys. And in order to give the datasheet information of the panel in the PVSys, we can make a click to open button, and after that the ICG current, short circuit current, the MPP current, open circuit voltage, VOC, and MPP voltage is given. As you can see in the CAD file, it says, and in order to make a verification for that, it says the open circuit voltage is approximately 450 volt. What I mean is 49.9 volt. And when we come back to PVSys for the open circuit voltage, it says 49.74. Approximately they are same with each other. We can go with that values to conduct our simulations. There is no problem with that very tiny differences. And when we come back to our AutoCAD file for the MPP voltage value, it says 41.96 volt, and when we come back to PVSys, it says 42.15. It can be regarded as approximately same again. And another crucial part is the IMPP and VMPP. ICG or short circuit current, and IMP IMPP, I mean MPP current. For the MPP current, in the CAD file, it says 13.11. In the PVSys, it says 13.07. It can be regarded as okay again. And for the short circuit current, for the ICG, it says it's 14. And for the ICG of the Schmidt-Pekintosh, it says 13.86. It can be again regarded as approximately the same. And since we make a verification with our datasheet informations, also we can make a verification about the dimensions of the panel selection. In our CAD file, it says the width of the panel should be approximately 1134, and for the length of the panel, it says it will be approximately 2280. When we come to size and technology section, as you can see, for the length, it says 2278 millimeter. It is approximately same with our length in the CAD file. And for the width, it says 1134, and it is exactly same with the width of our panel in the CAD file. After verifying that sections, we can click OK. And also for the model parameters, there are more specific and technical related information that is about choosing panel. There is a lot, also additional data, the degradation values, I mean the measured IV curve. There are lots of details and other videos that are so long topics, I think, and these are the so extensive topics. And in another videos, maybe we can make another video and record about the and talk about the these extensive topics. And just for our project, the basic data and the size and technology is the most important part for us to make a verification. We will click OK, and after clicking OK, we come to the inverter selection. For the inverter, actually, I will choose Huawei, and what I will choose. I choose a brand as the Huawei, but coming for the model, I have to again go back to our CAD file, and it states or AC power should be, total AC power should be approximately 200 kilowatt electric. And in order to attain this kilowatt AC, I want to choose, I try to look, okay, I want to choose, yes, that inverter. And it says it is 110 kilowatt AC. And when I use two of these 100 10 kilowatt AC inverters. By making multiplication with the 2, we will attain approximately 220 kilowatt AC power for our system. I try to be careful about to exceed the value of the 200. I mean, we said that for our selected brand and the model, the AC power of one inverter is 110 kilowatt AC. In that scenario, we have to choose two inverter and we will attain 220 kilowatt AC that is greater than 200 written in the CAD file in order to be in a safe region, because there may be some losses as we know within the system. In order to be in a safe region, I try to choose the the inverter power and also the number of inverters, so that we are a little bit above the kilowatt AC power that is written in the CAD file. Okay, and it says to use the multi-MPPT feature. Generally, we will not select this multi-MPPT feature, and instead of that, we will write the number of inverters. In our case, we said that the 2 inverter is enough for us to attain. As you can see, it wrote as the 220 kilowatt AC. Okay, and when we again click the open, the inverter datasheet information is given for us. For example, the main parameters, the maximum current per MPPT, the nominal MPPT voltage, the maximum MPPT voltage, and related technical details. Okay, as you can see, there are lots of labels, additional parameters, output parameters, size, and the technology. I mean, the size of the inverter is given, also commercial data is given. There is so much details in another videos. For other videos, we can delve into the details of that part. But just for doing project, this is enough for us. I will click OK. Okay. And also it says, as you can see, the input maximum voltage. What it means? It means the amount of the voltage that comes from the strings of the panels. I mean, strings that is constructed from panels. The DC input voltage should be maximum as 1100 voltage for that inverter, and the operating voltage will be a minimum 200 and maximum 1000 voltage, as you can see. And it says this inverter with 10 MPPT. I mean, this inverter, this Huawei Technologies Sun 2000 KTL has 10 MPPT in each inverter. And as you can, okay, it says the inverter with 10 MPPT. When we again open to datasheet information, in the additional parameters part, it says the number of MPPT input is 10. What that means, this inverter has 10 MPPT. This inverter has 10 MPPT, and each MPPT has 2 inputs. What it means, we have in one inverter we have 10 MPPT. In each MPPT we have 2 inputs, means we can connect 2 strings to that 2 inputs, and the multiplication of 10 with 2, we will connect at most 20 string for the one inverter that we choose for our system, we can say. Okay, and also it says string inverter, number of strings input. As we say, it is 20. It corresponds to 20. And we will click OK. After clicking OK, we will deal with the design, the array, the number of modules and the strings. Firstly, it will say module in series. What it means, it wants us to exactly specify the number of panels that will be used just in one string. And it says, according to the PVC say us, according to your chosen panel and inverter, you can say that my number of panel in one string will be between 6 and 20. And in order to attain the maximum output power, I will try to choose the 20 actually. But since how can I say, the design is done previously, we have to obey the AutoCAD file. And in our AutoCAD file, as you can see, when we open it, as you can see, this is just one string. And this is another string. This is the another. And each string has 18 panels in itself in our previously designed CAD file. And also the same numbers, 18 panel is valid for other sides of the roof. And as for coming to below part of the roof, that part, the person who designed this panel placement cut the design, divide the design to upper side and lower side, upper side and lower side. And on the lower side, again, the strings is composed of 18 panels. And you can ask a question about why that section is, sorry, why that section is not added at the end of that panel. Because of the area restriction, sometimes panels can be, how can I say, placed like that. And in Turkish, it is called yılanlama, like a snake shake is attained when we are trying to make the placement of the panels. It is like we come to that panel and we complete the string with the 10th panel like that. 11, 13, 14, and we come to 18, and we are going like, we are going like that. This is the flow of the, how can I say, the string placement. And we will say that this is one string this is the one string that includes 18 panel, and this is the another string again that includes 18 panel. And when we come back to our PVSys, we will write approximately the number of panels that is located in one string will be 18, and the number of strings, it says what is your number of strings. When I came to the AutoCAD file, as you can see, this is the first string. How can I say? Yes, this is the first string. From that strings, how many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have 16, and also 16, 17, 18, 19, 12, 21, 22, 23, 24. We have 24 strings, and each strings we have 18 panels. We can make a multiplication. For example, For the multiplication, we can say we have 24 string, and each string we have 18 panel. We will attain the 432 panel for our system. What we will wrote in the string section, we will wrote we have 24 panel for our 24 string for our panel, for our system, sorry. As you know, sometimes there can be, how can I say, the warning can occur in that section. For example, in order to understand what are these, how can I say, warnings that we can encounter in that section. For example, when we increase the number of module, number of panel in a one string, it says your array open circuit voltage at -10 Celsius degree is greater than the inverter absolute maximum input voltage. We are exceeding when we connect the panels in a string and strings to strings. When we connect the strings, after we connect all the strings together, it says your open circuit voltage at -10 degree is greater than your inverter absolute maximum input voltage. But what that means for us, for example, we will discuss these kind of errors, these kind of warnings in the upcoming video. We will try to discuss about these details in a more deeply manner. For example, let's go back to our accurate number of module in series, but let's assume that we are decreasing the number of strings in our system. It says the inverter power is slightly oversized, or if we continue to decrease the number of string in our system, it says the inverter power is strongly oversized. What I mean is there are approximately 3 main warnings that we can encounter in that blue section. In order to understand what that means, what that warnings tell us, we will record another video and the upcoming video we will try to, as I said, we will try to understand these kind of warnings so that if we can encounter, there will be no problem for us. Okay, let's go back to our original system. 24 string, and each string we have 18 panel. And as you can see, it says in the orientation 1, it wrote 10, and for the orientation 2, it wrote 14. But what that means for us, it is the number of strings that should be located at the one side of the ridge of the roof and other side of the ridge of the roof. In order to verify that, let's click our CAD file. As you can see, for the just one roof, for example, for that section or for that section, it doesn't matter. We said that these two roofs stay side by side and they are same. For example, just for thinking this roof, the number of strings that is located on the one side of the roof, what will be 1? This is the, as we said, this is the one string. This is one string. What we have? 1, 2, 3, 4, 5. This was the 5, 6. And for the other strings that face towards the same direction, again we have 6 strings. And totally 6, we have 6 for that section and 6 for that section. And since these strings, the first side of the first roof and the first first side of the second roof, since they face towards the same direction, we will say in the orientation one, totally we have 12 strings. But for the orientation two, what I mean, for the strings that is located on that section, I mean the second section of the first roof and the second side of the second side of the second roof, since they face towards the same direction, and we said that this is the orientation too. Again, we have totally 12 panels, 12 strings. Six of them is here. Four strings in the upper section and 2 strings in the below section. We have 6 strings for that section, and others. And for the second side of the second roof, we have again 4 string, 1, 2, 3, 4 string in the upper section, and 1, 2. 2 strings in the lower section. Thus, we have 6 string more again. And we can say for the orientation two, totally we have again 12 string. What we will wrote in our previous section, we will say for the orientation one, totally we have 12 string, and for the orientation two, again we have 12 strings. Actually, as you can see, for the right hand side, we have a global system summary. It gives us number of modules that is used in PVCs in our system. For the module area, it gives the module area, how the PVCs attain the information of the module area. As you can remember, for the PV module section, we had the size and technology section. The length and width of the panel is given automatically in PVCs. From that section, it calculates the module area, total module area, and we said that the number of inverters should be 2, and it calculates the nominal power as 236 kilowatt peak DC. Since it says the kilowatt peak, we should understand, yes, it is in the DC form. This power is coming from the panels, not from the inverter. It is not the version that is converted to AC form. And for the nominal AC power, it says 220 kilowatt AC. This is the converted version of the DC power, and it says the phenomenon ratio is attained at 1.08. And this, as we said before, this phenomenal ratio is attained at DC power over AC power. This was the end of, or this is the end of our lecture actually. In the upcoming lecture, as I said before, we will try to focus on the warnings that we may encounter in that blue section. See you again in another lecture.